Imagine you're at a diner and you hand an architect this old coffee-stained napkin sketch.
Well, right, with just a couple of wobbly rectangles drawn on it.
Yeah, exactly. And maybe you scribbled a little note that says, I want lots of natural light or something. And then you expect them to just hand you back a flawless, code-compliant blueprint for a 60-story skyscraper.
Right, which you would never do. I mean, inherently, the fidelity of a napkin sketch just can't support the weight of a real building.
Never. But, that is actually exactly what you are doing every single time you sit down at your laptop, you type out this fuzzy 3-paragraph, super conversational English prompt, feed it into an AI, and hit enter.
And you just expect magic. But it is, honestly, the single biggest bottleneck in knowledge work today.
It really is. Okay, let's unpack this. Today, we are doing a deep dive into the ultimate translation layer. We're looking at what happens when you stop drawing on napkins and start writing in a language that, well, it forces your own brain to be structurally honest.
We have culturally conditioned ourselves to believe that if we just, use enough adjectives and string enough polite sentences together, that clarity will naturally emerge.
Right? Like being polite equals being clear.
Exactly. But as anyone who has tried to get a highly specific output from a large language model knows, more words usually just create more fog.
Which brings us to the core of today's deep dive. We are exploring a notation system called HumanCode. It was created by David Caldecott, and the premise is just fascinating.
It really is. The question he asks is, what if there was a shorthand for thinking? Like a syntax that strips away all the decorative fluff of the English language.
And just leaves the load-bearing beams of your actual thought. And for you listening to figure this out, we aren't just skimming some random blog post. We have a very serious stack of source material today.
Yeah, we're talking full-on GitHub-style documentation. We have the official readme file, which really sets the philosophical groundwork for the whole thing.
Plus, the comprehensive master reference file. And that ledger of canonical practice examples, which is basically the Rosetta Stone for this entire system.
Right, and it even includes the raw instructions used to train an AI skill to read and write this specific dialect, so it's incredibly thorough.
So you, listening right now, you know this struggle. You sit in a meeting, you take a whole page of notes, and then 3 days later you look at them and have absolutely no idea what the actual strategic takeaway was.
You're just completely drowning in information overload.
Exactly. So our mission today is to give you the shortcut to bypassing that overload. We're going to break down how HumanCode works, why your current AI prompts are completely failing, and how this could fundamentally rewire how you interact with machines.
And honestly, how you interact with your own thoughts. I think the best place to start is right where the readme starts, because it forces us to confront this reality that most tech companies really do not want to talk about.
Oh, you mean the idea that the AI is actually no longer the problem?
Yes, exactly. The AI is not the problem anymore.
That is such a counterintuitive premise. I mean, the entire narrative for the last 5 years has been all about the models getting smarter.
Right. Everyone's asking, how do we increase the parameters? How do we build better neural networks?
But Caldecott is arguing here that the actual failure point isn't downstream in some massive server farm anymore. It's upstream. It's literally sitting in the chair at your desk.
Precisely. The bottleneck is the fuzzy conversational English we use. Just think about the language you use in a typical corporate setting.
Oh, it's terrible.
It is. You might write something like, I feel like we should maybe lean into this new marketing strategy.
I have absolutely written that exact sentence or, something very close to it because it feels collaborative, right? It feels polite.
Definitely feels polite. But what does it actually mean mechanically? Let's dissect that soft verb, feels.
Right, because feeling something isn't a strategy.
Exactly. When you say, I feel, you are taking a massive cognitive shortcut. You're hiding multiple separate decisions, maybe historical biases, and all these unverified assumptions inside one single syllable.
Wow, yeah. So the moment you use that word in a prompt or in a strategy document, the fidelity of your actual intent just plummets.
Because the AI or even the colleague reading the document has to guess what is actually powering that feeling. They have to fill in the gaps of your napkin sketch.
And that forces the AI to hallucinate your intent. It'll politely read your fuzzy paragraph, interpolate what a typical human usually means by lean into, and spit out this totally generic response.
Exactly. Which is why Caldecott argues that human code isn't just a way to make it easier for the AI to read. Its primary function is to force the human to clarify their own thinking first.
I have to admit, my initial reaction to this whole concept was a little defensive because, the whole multi-billion-dollar promise of large language models is natural language processing.
Right, the pitch is that the machine is supposed to understand you natively.
Yeah. Why on earth should you or I have to learn a whole new syntax? Shouldn't the machine be doing the heavy lifting of figuring out my messy thoughts?
It's a super common reaction. But here is the underlying mechanism you have to understand. AI does not experience language the way we do.
It maps it, right?
Yeah, it maps words into a high-dimensional vector space. So when you give it a messy, ambiguous sentence, it maps to a very broad, generalized area of that space.
So it's basically just giving you the statistical average of human thought.
Exactly. If you want a hyperspecific, structurally sound output, you simply cannot feed it statistical mush. But more importantly, the human code system acts as a mirror for your own intellect.
A diagnostic tool. I love that phrasing.
Caldecott explicitly notes this in the documentation. He says if you're trying to translate a thought into human code and you find you just can't do it, you haven't failed at learning the notation.
Right, you've just discovered the exact point where your thinking stops being clear. If you can't express it in the shorthand, it means you don't actually know what you're trying to say.
It is a really harsh mirror to look into.
It is, but, okay, if clarity is the goal here, how do we actually get there without turning into full-blown computer programmers? Because the second I look at a screen full of Python or C++ in, my brain just completely shuts down.
Oh, totally. Mine too.
I'm not a developer. I just want to take better notes and, write better prompts.
And that is exactly why the system is bound by 4 ironclad rules. These constraints are the only thing keeping human code from descending into unreadable machine code.
Right. Every single symbol, every abbreviation, every structural move has to pass these 4 tests. Let's test these rules out because this is the guardrail that makes the whole thing function.
Okay, rule number 1. It must be typable quickly by an average human on a standard keyboard.
Which is huge. It's about preserving the flow state of human thought, right?
Exactly. If you have to stop thinking about your actual idea to go hunt down a specific symbol, the notation has failed right then and there.
Which totally explains the banned symbols list in the master reference. And I'll be honest, some of these bans really surprised me at first.
Like which ones?
Well, it bans the therefore symbol. Those 3 little dots arranged in a triangle.
Right.
It bans the Greek sigma symbol for sum. It bans the integral sign. And those mathematical approximately equal to squiggly lines.
Right. And why do you think people are so tempted to use those in the first place?
Because they look smart. Honestly, if I'm trying to compress my notes, dropping a therefore symbol makes me feel like I'm doing high-level propositional logic. It means exactly what I want to say, like A leads to B.
It does mean that logically, sure. But try typing the therefore symbol on your laptop right now.
I couldn't even tell you where to start. I'd probably be mashing Option-Shift-T and just praying.
Exactly. Or you'd have to open a browser, Google therefore symbol, copy, paste, highlight it, copy it, go back to your document, and paste it in.
And in the 20 seconds it took me to do all that, my brain completely dropped the fragile, complex thought I was actually trying to capture.
You sacrifice the speed of thought for a visual aesthetic. That is why human code relies strictly on standard ASCII keyboard characters.
So we're talking equal signs, pluses, minuses, greater than, less than, and those standard text arrows made of just a dash and a bracket.
Right. You have to be able to type it without breaking your cognitive stride, which flows perfectly into rule number 2.
Okay, rule 2. It must be readable without mental translation. The documentation actually calls this the ceiling of the system.
Readability is the absolute paramount constraint here. If you look at a line of human code and you have to solve it like a Sudoku puzzle, the compression has gone way too far.
Right, you shouldn't have a decode step, which leads right into rule 3. No maths or programming background required. You really don't need a computer science degree to read this.
And finally, rule 4. No more correct form, which is such a fascinating constraint to me.
Yeah, explain that one because it took me a second to grasp.
Basically, once a notation passes the first 3 rules, meaning it's typable, readable, and accessible, you just stop. You do not keep compressing it just for the sake of saving space.
So you wouldn't turn a concept into a 3-letter acronym just to make it visually shorter?
Right. You don't compress it into cryptography. The whole philosophy here is finding the exact sweet spot between fluffy, ambiguous English and dense, unreadable machine code.
It strips the decorative paint, but preserves the load-bearing beams. It really reminds me of the way a master carpenter writes a measurement on a piece of drywall before they make a cut.
Oh, that's a great analogy. How so?
Well, they don't write, I believe the optimal length for this board, considering the room dimensions, should be roughly 42 inches. They just write 42 with a hard arrow pointing to a slash mark.
Yes. It is lossless in the direction that matters. Cut here. Boom.
Lossless in the direction that matters. I love that. But establishing these rules immediately introduces this massive tension, right? Because we're creating the system primarily so we can communicate more efficiently with large language models.
This raises an important question, though. What happens when the LLM tries to use the system itself?
Oh, the AI is immediately going to want to optimize it.
Exactly. AI is absolutely obsessed with efficiency. Left to its own devices, won't the AI just try to turn human code into actual programming code?
The documentation is fiercely protective against this exact scenario. It draws a very hard line. This is distinctly not pseudocode.
Right. Like, for instance, there are no empty parentheses.
Yeah, you never write a word and then put empty brackets after it like you're calling a function in JavaScript. The doc says if you write something like establish safety with via competence in parentheses, you have failed.
That is an AI trying to write code. That is not human thought. The distinction is absolutely vital.
Pseudocode is a human trying to write something that looks like a machine language.
While human code is a human trying to write human thought, just with the structural ambiguity removed. So how do we actually do that? What are the mechanical moves that replace our standard English grammar?
Okay, let's dig into what the master reference calls David's dialect. These are the core moves of the system. And the most foundational one is Pascal case.
This is where you smash nouns together and capitalize the first letter of each word, right? Like making good sleep into one single word.
Yes, good sleep with a capital G and a capital S. And the cognitive mechanics behind why this works are profound. It's called concept binding.
Let's look at working memory for a second. The human brain can only hold about 4 to 7 independent items in its working memory at any given time.
Right, so in standard English, the phrase a good night's sleep requires the reader to process 5 separate words.
You have to hold all 5 of those in your mental RAM, process their relationship to one another, and then synthesize them into a single concept.
But what happens when you write good sleep as one unified word?
You instantly bind the concept into a single visual token. Your brain no longer processes good as this isolated adjective modifying sleep.
It processes good sleep as a unified, independent entity. It reduces the cognitive load from 5 items down to 1 item.
And crucially, this is exactly how an LLM's tokenization process works.
Wait, really? Explain how the AI sees that differently, because this is the piece that I think most people, including me, didn't fully grasp at first. Why does the AI care if there are spaces between the words?
Because to an LLM, words are broken down into tokens. The phrase a good night's sleep might be mapped across 6 or 7 different tokens, and those tokens are scattered all across different semantic areas of the AI's vector space.
Ah, so good maps to positive things and sleep maps to rest.
Right. The AI has to expend actual compute power to pull those vectors together based on their proximity in the sentence. But when you write good sleep in Pascal case, you are handing the AI a novel, unified token sequence.
You force a specific, hard-coded semantic binding. You completely eliminate the statistical ambiguity.
That is wild, isn't it? It's like creating a custom compound word on the fly,
Yeah.
and the AI is forced to accept it as a single unit of truth.
Okay, so what's the next major move in the dialect?
It's how it handles prepositions. Words like on, than, for, under. In HumanCode, you write these using underscores and all caps X. So underscore on underscore or underscore than underscore.
Visually, it just jumps right off the page. If I'm looking at a dense block of text, those capitalized underscored prepositions act like high-visibility traffic signs.
They act as the structural glue. They tell your visual cortex, hey, this is the precise logical bridge between the concept on the left and the concept on the right.
You don't have to hunt for the relationship. It is basically screaming at you.
Which brings us to my absolute favorite move in the entire system, intent labels.
Oh, yes. This is where you use a colon to declare exactly what a line is doing before the line even starts.
Right, you write math or reason or proposal instruction right at the front.
Think about how much friction this removes from everyday communication. In standard English, particularly in business, the intent of a sentence is almost always buried.
Oh, always. You have to read an entire paragraph of context and throat clearing before you finally reach the last sentence where the person asks you to actually do something.
It's the classic corporate email, right? Hope you're having a great week. As you know, we've been looking at the Q3 numbers and there's been some fluctuation. Oh, by the way, I need the updated budget by 5 p.m.
Exactly. You had to spend precious mental energy parsing those first three sentences, just trying to figure out what cognitive framework to apply.
Right, like, is this an update? Is this a warning? Is this just a social check-in?
With an intent label, the parsing work is done in advance. By starting the line with proposal instruction, you are telling the reader, whether it's a human colleague or an AI, exactly what lens to use to process the following data.
It eliminates the cognitive tax of decoding intent. Now, what about parentheses? The rules say they are allowed, but strictly for natural English context, never for code.
Right. You use brackets to hold little hints, modifiers, or conversational context in plain English. It preserves the human voice without polluting the structural logic of the main line.
Okay, I see the logic in all of these individual moves, but I have to be honest here. When I first looked at a full page of this, well, it feels clunky.
It does look different, yeah.
If I'm reading standard English prose, my eyes just glide over it. It's a very smooth experience. Doesn't smashing words together in Pascal case and shouting prepositions and all scapies make the actual act of reading much harder?
It does make it harder to skim, yes. But we have to be honest with ourselves about what gliding over text actually means.
What do you mean?
When your eyes are gliding smoothly over a corporate strategy document, are you really deeply comprehending the structural logic, or are you just absorbing a general vibe?
Ouch. Yeah, okay. I'm usually just looking for my name or an action item.
Exactly. Smooth reading is often shallow reading. HumanCode intentionally introduces friction. It asks the reader to slow down.
Because when you strip out the filler words, what remains is incredibly dense.
It requires focus. The compression is evidence of clear thought, but it demands that the reader actively engage with that thought, rather than just passively gliding over it.
So, what does this all mean? Let's see how this friction actually plays out in practice. The documentation includes this amazing section called the canonical example.
It's a record of 2 live practice translation sessions done by Caldecott in April 2026. This is where the theory actually hits the road.
We have to analyze these carefully because they reveal the hidden mechanics of the dialect. Let's start with a simple one from round 1.
Okay, if I tell you a good night's sleep equals a better mood the next day, how would you normally try to shorthand that in your notes?
I'd probably just strip the articles. I'd write, good night sleep equals better mood next day.
That's the natural instinct. But here is the exact HumanCode translation from the documentation. It's one good sleep beat his better mood on next day.
Okay, let's break that apart. We have the equal sign acting as the assignment operator. We see the Pascal case binding good sleep and better mood.
Right, and we see the all CKPS preposition on Salakad acting as the temporal bridge to next day, but what really jumps out is how it handles the adjectives.
Notice what happened to the word better. Better is a comparative adjective. In the original fluffy English sentence, a better mood is just a vague positive feeling.
But in the HumanCode translation, better mood is explicitly bound to the temporal modifier on next day. The line commits to a very specific causal and temporal relationship.
And Caldecott added a number. 1 good sleep, 1 unit of good sleep. He quantified it.
Yes. The translation process forces implicit assumptions to the surface. Let's look at another one from the docs. Source text. 5 clients at £2,000 each is £10,000 a month.
And the translation is, math. 5 clients at 2 km each exceeds 10 kilometers.
Look at the sheer efficiency of that line. The intent label math primes the reader immediately.
The hat symbol handles the rate of. The M unambiguously handles the time-bound reality of per month.
It compresses a 12-word sentence into an airtight equation that an AI can parse flawlessly with zero hallucination risk.
It's mathematically beautiful. But math is easy to compress, right? Human beings aren't math. We run on emotions, physical states, and totally irrational things. Let's look at how it handles causation with human states. The source sentence is, he hasn't slept, therefore he's grumpy.
And the HumanCode is, he has, sleep debt, expect, grumpy.
This is where I initially pushed back on the system. The original sentence says, he hasn't slept. That is an action, or rather a lack of an action.
Right.
But the translation introduces sleep debt. That is a totally new concept. It's a physiological state. Doesn't that violate the rule of just translating what's there?
That is the genius of the diagnostic mirror. He hasn't slept is indeed an action, but why does a lack of action lead to the emotional state of being grumpy?
The invisible link.
Exactly. The thing the original sentence left fuzzy is the physiological reality of deficit. By forcing this into human code, Caldecott couldn't just rely on the vague word therefore.
He had to articulate the actual mechanism of causation. The state is sleep debt.
Oh, wow. It forces you to define the mechanism, not just the symptom.
Yeah.
And look at the punctuation. He has sleep debt, expect, grumpy.
There's no arrow. There's no mathematical logic operator linking them. There is just a period between the two concepts.
This is a masterclass in relying on human intuition. The period implies causation purely through adjacency. We read state A, period, state B.
And the human brain naturally bridges the gap. The system doesn't need to bloat itself with some weird Leadstoth conclusion that function call. The period does the work, provided the reader is paying attention.
Exactly. Those are basic scenarios, though. But life, particularly professional life, is rarely that clean. Projects get messy. Office politics get involved.
So how does a system this rigid handle deep subjectivity and emotional nuance?
That brings us directly into the deep end. Round 2 of the canonical examples, the harder sentences.
Here's where it gets really interesting. This is where we test if the system can handle the weight of human experience without stripping out the humanity.
Let's look at the emotional mapping example. The source sentence is, the project without Tom feels 10 kilos lighter.
Think about how subjective that is. It's profoundly human. How do you apply structural logic to a feeling without destroying the poetry of the thought?
The HumanCode translation is, impact of feelings, project without Tom equals 10 kills lighter.
This specific translation is arguably the most important line in the entire documentation. It solves the subjective problem brilliantly.
It creates a function call frame, but not for code execution. Impact of feelings.
It's like applying a photography filter. The underlying image, the project hasn't changed, but we are explicitly labeling the lens through which we are viewing it. We are looking at the impact of feelings lens.
That is the perfect analogy. It doesn't strip the subjectivity away. It frames it explicitly. And look at the embedded preposition without Tom.
And keeping the unit 10 kilo lighter. It embraces the metaphorical weight alongside the literal structure.
Let's look at the final, most complex business narrative from round 2. The source is, the company is dissolving, but the IP isn't the agents, the frameworks, the notation all survive as my portfolio, and that's the quiet win underneath the loss.
That sentence is an absolute nightmare for a standard AI to parse accurately. It contains legal status, asset lists, emotional resilience, spatial metaphors, and a complex narrative pivot.
What's fascinating here is how Caldecott wrestles this into human code.
Right.
He writes, status dissolving, April 2026. Patino Pecan, IP agents, frameworks, notations survive A's. My portfolio, a quiet win under loss.
Look at the sheer invention of new structural moves there. It's breathtaking. First, the inline intent labels. He turns a verb into an intent label with survive A's.
And the summary arrow, the equal sign and a greater than sign making the symbol.
Exactly. The standard text arrow implies sequence or flow, but the double-line summary arrow implies all of the preceding complexity resolves into this final state.
And then ending with the positional preposition under, quiet win under loss. The spatial metaphor is perfectly preserved. It encodes the feeling, the rhythm, and the business reality simultaneously.
This proves that human code isn't a static, rigid dictionary. It is a living dialect. It evolves based on what the human needs to capture.
But this level of flexibility introduces a massive vulnerability. We've seen how a human uses it correctly. What happens when an LLM tries to write it?
The documentation includes a section on AI overreach, and they log the actual session errors where the AI tried to improve the notation. And honestly, it is both hilarious and terrifying.
It perfectly illustrates the philosophical divide between human cognition and machine processing. Let's go back to the sleep example. We know Caldecott's correct human version is one good sleep, better mood next day.
Right. When the AI was asked to translate that same sentence, it output sleep, good, mood, plus A, next day.
Why does that fail our 4 ironclad rules?
Well, structurally, it uses a fancy Unicode arrow instead of the ASCII text arrow made from a dash and a bracket. So it immediately fails rule 1. Typability, you can't type that quickly.
But the cognitive failure is much worse. Look at sleep. Good. It turns a unified concept into a function call with a parameter.
It forces the human reader to parse sleep parameter good instead of just absorbing the bound concept of good sleep.
It breaks rule 2. Readable without mental translation. The AI optimized for programming logic, and in doing so, destroyed human readability.
Let's look at the grumpy example again. The AI's attempt was minus sign, sleep, the three dot, therefore symbol, grumpy.
Again, completely untypable because of the therefore symbol and the Unicode minus sign instead of a standard hyphen. But beyond typability, look at how soulless it is.
Compared to Hiha's sleep debt expect, grumpy, the AI version feels like a sterile math equation.
It completely loses the nuance of the physiological state. The documentation warns about this specific AI behavior. AI loves cryptography. It loves maximum compression.
Left unchecked, an LLM will just try to sound like a machine. It will also try to create what the documentation calls container words.
What exactly is a container word in this context?
If you ask an AI to structure a complex strategy, it will try to wrap your thoughts in bloated categorical labels. It will output things like strategic logic block and then put goal, win in brackets, or it'll name things node alpha.
Right. It tries to build a software architecture out of your sentences. HumanCode explicitly rejects this. You label the concept itself, not the container holding the concept.
It is deeply ironic. We created this system specifically so the AI could read our thoughts more efficiently, but we have to build aggressive guardrails to stop the AI from improving it.
Because the AI's idea of an improvement makes it completely illegible to the human beings who actually have to maintain it.
The human in the loop is the ultimate final arbiter of readability. If the human has to decode it, the notation is wrong, even if the AI's version saves a few extra tokens.
So we've explored the theory. We know the rules, we know the dialect, and we know what the AI gets wrong. But how do you, the person listening right now, actually use this tomorrow morning?
How does this exist in a real-world workflow?
The master reference outlines two distinct modes of practice: background mode and active mode. Let's start with background mode because this is where the system scales beautifully without increasing your daily workload.
This is the AI talking to AI scenario. I was fascinated by this. How do you set this up?
Imagine you are writing your normal, long-form, fluffy meeting notes in a standard markdown file. Let's call it projectupdate.md. You write it exactly how you normally do, full of adjectives and conversational context.
But you configure your AI assistant to silently, in the background, generate a companion file.
A companion file using the stacked extension, .hc.md.
Yes. The brilliant simplicity of that .hc.md extension. It renders seamlessly in GitHub, Obsidian, VS Code, or whatever markdown tool you use.
It maintains complete backward compatibility with your software, but it waves a flag to the system saying, hey, this file contains human code.
So I have my original file for human eyes and this hidden .hc.md file running alongside it. Why? What is the practical benefit when I log in the next day?
Because the next time you ask your AI a question about that project, the AI doesn't need to load your 5 pages of fluffy notes into its context window. It targets the .hc.md file instead.
And the documentation says this achieves 70 to 80% compression.
Oh, wow. So from a purely mechanical standpoint, it costs fewer tokens, it loads into the AI's memory faster, and there's zero ambiguity for the AI to hallucinate over.
Exactly. If we connect this to the bigger picture, it fundamentally changes how we store personal and corporate knowledge.
Historically, you had to make a painful choice. Do you write dense, bulleted lists that the AI can easily parse but lack all human nuance? Or do you write long prose that preserves your voice but confuses the AI?
Background mode lets you have both. High-fidelity prose for human enjoyment and hyper-compressed structural truth for AI parsing sitting side by side.
The documentation gives this incredible example of an email investor note. It's a real long-form email pitch from a founder to an investor, and attached to it is the HumanCode companion file.
The idea is that an absurdly busy investor, or more likely, the investor's inbox triage AI agent, can read the .hc.md version in 60 seconds. They instantly understand the exact structural pitch, the funding tracks, and the explicit ask.
But the original prose version is right there to preserve the founder's passion and narrative voice if the investor decides to dig deeper.
It is the ultimate display of respect for the recipient's time without sacrificing the humanity of the message. But background mode is mostly automated. The real diagnostic power comes from active mode.
Active mode. This is where you and I actually sit down and write the human code ourselves. And a lot of listeners are probably thinking, okay, I can use this to make my prompts shorter.
And yes, that's true. But the documentation highlights a much more powerful use case: voice profiles and custom AI agents.
This completely changes how you build custom GPTs. Let's talk about the Donna profile mentioned in the text. Donna is described as a fierce, confident receptionist.
Now, if I am trying to build a custom GPT to act like Donna for my customer service portal, my instinct is just to write a system prompt that says, "You are Donna. Act like a fierce, highly competent receptionist. don't take any nonsense from rude clients.
And if you write that paragraph, what does the AI actually do?
It probably starts acting like a caricature. It pulls every cliche of a sassy receptionist from its training data, mixing in Hollywood movie tropes, and ends up being wildly inappropriate to actual customers.
Precisely. Because fierce is a fuzzy, subjective vector.
Mm.
But if you write the Donna profile in active mode, using human code, you aren't suggesting a vibe. You're encoding the structural behavior of that emotion.
You use explicit logic to bound the personality. So instead of saying be fierce, I would write something like IF client LMS response,
Yeah.
unapologetic correction.
Exactly. You define the operational boundary of the personality. You dictate the precise conditions under which she pushes back.
It preserves the emotional charge because it structurally mandates how that emotion is deployed.
That is incredibly powerful for anyone building automated workflows. But to really master this, for you listening, to actually internalize how to do this, we need to look at the documentation's ultimate diagnostic tool.
The teaching method called cut it down.
Cut it down isn't just about learning syntax. It's about rewiring how you observe your own thoughts. You take a standard, rambling English sentence, and you iteratively compress it in passes.
I want to spend some real time on this because seeing the intermediate passes is where the magic happens. Let's look at the example sentence. It's a 214-character marketing thought.
It says, if we ship human code publicly, we need real examples, not marketing copy, because the 76% compression number is a real thing, but the Donna profile is what actually makes people believe the notation carries meaning.
We have all written sentences exactly like this. It's a classic, multi-clause, slightly rambling thought. It has conditional logic, a defensive justification, data points, and an emotional claim all mashed together.
So, pass one. If I'm looking at this, my first instinct is just to strip the connective grammar. So it becomes, if ship human code publicly, need real examples, not marketing copy. 76% compression is real, but Donna profile makes people believe it has meaning.
That is standard note-taking. You've removed the fluff, but you haven't fundamentally altered the structure. It's still a paragraph.
Now, apply pass two. The core moves. Introduce Pascal case and explicit logic operators.
Okay, applying Pascal case. Ship publicly becomes ship publicly. Real examples becomes real examples. So now we have IF ship publicly, need. Real examples, not marketing.
Look at how much sharper the front half of the thought is already. IF ship publicly, need. Real examples, not marketing. The logic is explicit.
And the parenthetical, not marketing, acts as a perfectly constrained human hint. But the back half of the sentence is where the real diagnostic work happens.
Right, the part that goes, because the 76% compression number is a real thing, but the Donna profile is what actually makes people believe the notation carries meaning.
Okay, let's apply pass three. Intent labels and concept binding to the back half. We start with the intent. Why are we talking about the 76% number? It's the justification. So, reason. 76% compression, execs.
Good. Now tackle the final, messiest clause. But the Donna profile is what actually makes people believe the notation carries meaning.
Okay, BUT, Donna profile. Wait. Makes people believe the notation carries meaning. How do I Pascal case that? Makes people believe. That's too long.
What is the actual function of the Donna profile here?
It's an engine that generates belief. So, belief engine.
Yes. And let's read the final 96-character human code result.
Okay.
IF ship publicly, need. Real examples, not marketing. Reason, 76% compression. Fact, BUT Donna profile equals belief engine.
Donna profile the belief engine. That is structurally breathtaking. And here's the crazy part. The word engine wasn't even in the original 214-character sentence.
That is the profound realization of the cut-it-down method. By forcing the thought into a concept-binding Pascal case noun, the author didn't just summarize the sentence.
They discovered the actual underlying mechanism they were trying to describe all along, a belief engine.
You cannot hide a fuzzy thought behind good grammar in human code. The act of translation forces the bones of the thought to the surface.
It is a mirror for our own intellect. If you sit down to write out your teen's quarterly goals or the logic for your side hustle, and you find you cannot compress it into human code, you haven't failed.
You have just successfully diagnosed exactly where your strategy is hollow. That is where the real work begins. The notation doesn't solve your messy thinking. It illuminates it.
So, for you listening, think about the last time you tried to write a complex prompt for ChatGPT, or the last time you stared at a messy page of meeting notes. Next time you feel that overwhelm, try mapping it out.
Smush your important concepts together with Pascal case. Build your logic bridges with all CCAP-ES prepositions. Stick an intent label at the front of the line.
You aren't just saving tokens, you are forcing yourself to be honest about what you actually mean. You are building a structural blueprint instead of sketching on a napkin.
And once you train yourself to see the underlying architecture of your thoughts, it becomes very difficult to go back to writing the fuzzy, comfortable stuff we are all used to.
We have covered a massive amount of conceptual ground today. We started with the upstream bottleneck, the realization that our polite English is destroying the fidelity of our intent.
We locked in the four ironclad rules of typability and zero mental translation. We broke down David's dialect, the Pascal case binding, the intent labels, the summary arrows.
We saw how to map deep emotional subjectivity without turning it into soulless math. And we explored the critical danger of letting an AI try to optimize the notation into unreadable cryptography.
And most importantly, we looked at how to deploy this in the real world, setting up background.ht.md files for massive AI context compression, and using active mode to forcefully diagnose the gaps in our own reasoning.
You now possess a new mental framework, a genuine shorthand for thinking.
It is a powerful tool to navigate the noise of modern knowledge work.
It really is. But looking at the sheer clarifying power of the system leaves me with one final, frankly staggering thought for you to explore.
What's that?
Well, we built HumanCode to talk more efficiently to artificial intelligence, right? And to clean up our own personal notes. But if a structured shorthand like this forces us to be radically honest about our unclear thinking, what happens if we scale that demand for clarity?
Oh, wow.
What happens to our societal debates or our interpersonal relationships if we started demanding this level of structural honesty from our politicians, or our news media, or even our spouses during an argument?
Imagine a political debate forced to be transcribed into human code in real time. The rhetorical fluff, the pivoting, the emotional manipulation would evaporate. Only the actual mechanisms of their intent would remain on the screen.
What if the real revolution of this era isn't that AI is finally learning to speak our messy, fuzzy English, but that humans are finally being forced to learn how to say exactly what we mean? Keep tutting it down, everyone.